All right, at 6:30, we're back for our final go around, Chapter 9, Production and Operations Management. And we hope to address these learning goals as we go through this final hour or so. Describe the current state of U.S. manufacturing and what manufacturers have done to become more competitive. Describe the evolution from production to operations management. Identify various production processes and describe techniques that improve productivity, including computer-aided design and manufacturing, flexible manufacturing, lean manufacturing, big deal these days, and mass customization. And then finally, describe operations management, planning issues, including facility location, facility layout, materials requirement planning, purchasing, just-in-time inventory, and quality control. And we talked a little bit about quality control back when we were talking about the 4 functions of management. And then finally explain the use of PERT and Gantt charts to control manufacturing processes. Now, if you look on page 234, you're going to find some confusing information. And so you kind of have to go through it to make sure that you get the gist of what's being said here. It is still, the United States is still the world's leading manufacturer, regardless of what you read in the papers. And that's why I say you have to read this very carefully to make sure that you get the salient pieces. Manufacturing has continued to grow in the United States since 1970. And it's twice as large today as it was in 1970, even though, and this is the critical part, even though we have fewer manufacturing jobs, fewer people are employed in manufacturing. Almost 25% of goods produced each year globally come from the United States. Now you think about that. We are about 330 million population in the United States. China is over 1 billion. India is over 1 billion. So we produce a lot of stuff. We're just not given credit for that. Yes, we've lost manufacturing jobs. Yes, production has moved overseas. Yes, we have outsourcing, but we're still doing a pretty good job of manufacturing. And that's why I say when you read in the text, page 234 and page 2 part of page 235, it's a little confusing. So make sure that you read it closely and you get the right information. Here's what we still make in the United States: chemicals, transportation equipment, processed foods, etc., soft drinks, computers and electronics. So we're actually producing a lot of stuff. We're making a lot of stuff. We're manufacturing a lot of stuff. And I am using the word stuff, and I should say product instead of stuff. So it's still there. Do we have as many manufacturing jobs as when my father was a young person, or even when I was a young person? No. But we're still manufacturing a lot, and we're still growing as a manufacturing country, even though we've gone to a service economy. These are the states that export. If you just look at the top 3 states, I'll even talk about, top 3 states, they're all exporting in excess of $70 billion. A lot, that's a lot. And California, we wouldn't think as a manufacturing state. We tend to think a manufacturing state is the old Rust Belt: Michigan, Ohio, Pennsylvania, Illinois, New York to some extent, states like that. Indiana would fall into that category as well. I don't want to leave anybody out. I'm just trying to think of the ones that we tend to put in that area. Pennsylvania, if I didn't say it, I think I did. In California, 142 billion. And this is 3 years old. So it's maybe even close to 4 years old. So that's liable to have gone up since then. And then these are massive manufacturers that are companies in the United States: ExxonMobil, Ford, Hewlett Packard, IBM, Procter & Gamble. We don't always think of those companies, especially Procter & Gamble, perhaps Hewlett Packard, as being manufacturers. Archer Daniels Midland is another one. People may not even think about them as being a manufacturer. They are. And of course, what we're trying to do today in this thick and green on page 235 is sustainability. Companies are working on sustainable projects. Certainly Procter & Gamble is, and other organizations. DuPont, Michelin. Of course, Michelin is a French company, but Chevron is certainly not. These are the top service sector jobs in the United States. I'm not going to talk a lot about that, other than to say that manufacturing doesn't drive our economy anymore, even though we still have a large manufacturing segment. 85% of our jobs are in the service industry. I'm in the service industry. Perhaps each of you is in the service industry. We find some things that are different. But we still have a huge manufacturing output in the United States, and we have to think about that, and we have to champion that. Here's where we are finding that we are competitively in advance of our competitors. Nanotechnology and biotechnology. Now, one of the things that we have to pay attention to is this laundry list that you see here, how we can maintain a competitive edge. And notice what the first one is: paying attention to our customers, exceeding customers' expectations. Yeah, they didn't see that in there, but that's what we're after. There's one just a little further down, and I would move it up to second, and that's focus on quality. We have to have pride in manufacturing. We have to have pride in service. We have to have pride in whatever we do. But we need to focus on quality, because it's quality, putting out quality products that gets the customer to return. How many times have you bought something that you did not like, or you went someplace and you got poor customer service, and you voted with your feet, and your feet said, "I'm never going back in there again"? Well, your mind said that, but your feet didn't. Paid attention and walked out, never went back. How many times do we do that? We do it very often. And what do we do here when we do that? We do the company a disservice by not telling them, hey, this product didn't measure up. This service wasn't very good. I'll give you an example. My wife and I and some friends went to a very nice restaurant here in Cincinnati a couple of weeks ago. And I had to tell the waiter at the end of the meal that what I ordered wasn't as warm as it should have been. And the chef that owns this place has a national reputation. And so I wasn't denigrating them, but I was telling them, this isn't up to your standard. I'm not going to not go back. But if I go back the next time and I have the same type of product, I'll tell them, you either fix this or I'm not coming back. But other places I've gone, I've gotten bad service. I've just never gone back. So I don't need to do this. So we don't do people a good service when we don't tell them. We pay our money, and we want a good product. So there's some other things in here too. I'm not going to go through a whole lot of things, but it talks about saving on site selection. You're going to notice when you do the Ball video that Ball does that. And Ball, I don't want to steal the thunder. I want you I want you guys to pick this up. you ladies, because we just have women in this course. Pick this up. What Ball does, how Ball keeps its costs in control. What it does to do that. Didn't cut corners, still doing a quality product, but it controls costs in various and sundry ways. Look for that in the video. We need to learn from other countries. Investing in research and development. Investing in a highly trained workforce. One of the problems that we hear a lot of manufacturers talking about today, our workforce is not as skilled as it ought to be. Not just not as educated, not as skilled. Don't know how to use computers. That's an indictment on us. We need to do that. We need to promote that. Now, what this tells us here today, we've moved from production management to operations management. So production, we use the 5 factors of production, land, capital, entrepreneurship, knowledge, etc. And we did all those things. We put all those things in to create goods, product, to manufacture them. And that's what we did. And we didn't pay necessarily a lot of attention to doing anything other than taking these factors and increasing production. Well, that's all well and good, but if all we're talking about is making more widgets, and we're not paying attention to the other things that we need to do to still put out a quality widget and reduce our costs, and we're going to have problems. And so we've moved away from, and this is, by the way, this is a concept most manufacturers have taken this on, away from production management to operations management. And notice what this says here, and it's important to read this last part. It takes input resources and then transforms those resources into goods and services. And one of the ways we do this is we pay attention to these 4 areas, and we bring them into bear when we're doing something. Inventory control, quality control. Of course, I prefer to use the term quality assurance, production scheduling, and then the follow-up services. So that's more than just production. That's more than just making things. We've got to do the rest of these things to make sure that what we're making is a quality product. And we're going to get people to come back. Now, operations management is more than just with manufacturing. You can put it in the service industry. Look at the Ritz-Carlton Hotel. Now, in another course that I teach, and I haven't taught it for a while, but I used to teach, I used the Ritz-Carlton Hotel as a case study. And what they did and how they worked to enhance the customer's well-being while he or she was in their hotel, and what they did to do that. I'm not going to talk about these productivity apps for the iPad. I want to go on from something beyond that, so we can move forward. Now, this is the production process, and this is figure 9.1, which you can see at the bottom of page 239. And essentially what we do is we have inputs, and that's the 5 factors of production. And then those are inputs, and then we put them into a production process. Now this is called production control, and we do some stuff here. We do some planning and scheduling and dispatching, et cetera, et cetera. And then we have our outputs, which are finished products and services and ideas. We can't think of that intellectual property ideas. So that's what we do. Take the factors of production and then put them through the processes of production, which is the planning, scheduling, etc., and then we get outputs. Farm utility. This is where we, Mr. or Miss Manufacturer or Mr. or Miss Service Provider, take a product and add value to it, so that when it comes out of our service or our production, it is more meaningful to the customer. It takes on a greater value than it had before it got to us. Now, these three tenets here, if you will, basic requirements of production, come from a gentleman by the name of Andrew Grove. He was if you can see on top of page 240, the former chairman and CEO of Intel. Andrew Grove was a very unique individual because not only was he a good chief executive officer, he was technically competent. So he could go down to the research and development department and talk to those people in their own language. He understood, and they knew that he understood. So notice what he says here. To build and deliver products in response to what the customers want and get them to the customers when they want them. To provide, and I'm going to change this a little bit, to provide a level of quality that exceeds what the customer expects, because that's what we're trying to move to today. Not just acceptable, as he said, although there's nothing wrong with acceptable. Acceptable is fine. We're trying to move beyond that. And then to provide everything to the customer at the lowest possible cost. Now, that does not mean, and I want to say this, and please take this as I mean it, this does not mean cheap or on the cheap. What it means is doing everything we have to do to, one, reduce our costs in operations and production, and two, to deliver that saving to the customer, so that we're giving the customer what he or she expects. Hopefully we're exceeding what they expect at the lowest possible cost. But it's not cheap. We have to remember that. You know, I can remember I used to do business occasionally with Midas Muffler. And I walked into Midas and I had my car I had was, at that time, was probably 10 years old. And I sold it a few years later. It was 14 years old when I sold it. I needed a new muffler. And so they said, do you want good, better, or best? So they were offering me 3 levels of product, not service, of product. I could get one for the lowest possible cost. Probably wasn't going to last very long. I could get one in the middle, which is what I decided to do based on the age of my car, that was going to last more than this one, but it wasn't going to be quite up at the top. Or I could buy the top of the line and probably going to last me for a lot longer than I was going to keep my automobile. That's what we're talking about here, what Andrew Grove had to say. A couple of kinds of process and assembly of production. You have process manufacturing and you have assembly process. Process manufacturing is what you bring something in and you chemically change it to something different. I also physically changed it. I just keyed on the word chemical because I guess that's kind of how I think. Doesn't mean I'm right. It's I think that way. The assembly process is what it is that takes those components and puts them together and makes a whole. So we have two. We have process manufacturing, and then we have the assembly process. A couple of things we need to think about production processes. One's continuous process. That is exactly what it says. It is long running, a long production run that's going to give us our finished goods. Intermittent process is just the reverse of that. It's a short run, but the producer changes the machine, corrects the machine, that allows them to run other production, make different products, as the slide says, other production. These are just some of the products that can be made, number of products that could be made in a minute. Krispy Kreme donuts, Chips Ahoy, Twinkies, Jello boxes, etc. Lifesavers. I always like to use this as a talking point. I understand Krispy Kreme donuts are wonderful to eat. I've never had one. And now I'm not trying to tell you that I'm a health nut. I do watch my diet, but it's just something I've just never had one. It's just not something that interests me. Here are some things we need to think about, because this is the wave of the future. It's happening now, but it's the wave of the future. These four things. Computer-aided design and manufacturing. We'll talk about that in a second. That comes next. Flexible manufacturing, lean manufacturing, and then mass customization. All different processes, all different production methods or modes based upon what you want to do and how you want to do it. Computer-aided design, computer-aided manufacturing, a little bit different. In computer-aided design, the computer helps you design the product. Computer-aided manufacturing, you're actually using the computer in the manufacturing process. Now, you could do both, but it's just different. And think about that differently, CAD and CAM. Computer-aided manufacturing, excuse me, computer integrated manufacturing, CIM, C-I-M, unites the computer-aided design with the computer-aided manufacturing. So here you have two that were separate before, now you're bringing them together. And you should, if you do this properly, get economies of scale. Notice, though, it's expensive, but it cuts as much as 80% off production time. So this is something that really is, you have to look at, and you say, okay, well, this is expensive, but what do I save when I don't have to recalibrate my machines, et cetera, et cetera? So it could be a trade-off, or you could wind up saving money. So it's not something that should be rejected out of hand, but by the same token, it's not something that should be embraced without doing cost-benefit analysis. Flexible manufacturing is simply what it says. It's designing your machines to be able to manufacture more than one product. Allen Bradley, which is a well-known company in the Milwaukee area, does that. To do flexible manufacturing, to build motor starters. That's kind of the business that it's in. Lean manufacturing. I got to know something about this with a former student that I had. He worked for a very large company, and he went around to their manufacturing plants and taught them lean manufacturing. Now, what lean manufacturing simply says is doing your production with less of everything. Fewer humans, fewer raw materials, coming up with fewer defects in the manufacturing process, having less inventory on hand, etc. Now, when you do all these things together, it reduces costs, it reduces operating costs, it reduces overhead. And so then there's a lot of saving when you stop and think about that, because you've been able to cut back on what you've done. The biggest thing here is that they want to do, and they're all important, but one of the biggest things they want to do is to reduce scrap, unused material, or material that's been used that doesn't meet specification. I mentioned this before, that's quality, and the quality, when we talked about the fourth function of management control. You want to be able to cut that down, so you're not doing having a lot of scrap. Scrap is waste. You can't change that. I mean, you can call it anything you want to, but it's still waste. And if you have waste, that means that you've lost money. So you want to cut that down to, well, I was going to say manageable, but you don't even want to make it manageable. You want to cut it down to where it's almost minuscule. It can't be measured in some respects, or the measurement is very, very, very small. So that's what you want to do. But it also talks about taking less human effort. Now, it did not say fewer humans or fewer employees, but less effort. So there are ways that you do that. You develop your manufacturing so that, if instead of walking across the room to do something, you've moved a part of the operations over here, so all the person has to do is turn, as opposed to walking across the room. So there's all kinds of things that you do this, and it could be part of time and motion studies and a few other things, which that goes back to Fred Taylor. We'll talk about him next week. But this is what lean manufacturing is all about. Mass customization is just what it says here: tailoring products to meet customers' need on a large number of individual customers. So here you have mass customization, but it's not going to just one person, it's going to a bunch of other people. This is just some mass customization of candy, spotlight on small business. You can see this on page 243. Now here we get some more here about operations management. And operations management is more than production management, because production management focuses on production. So we're thinking here about facility layout. We're thinking about location. We're thinking about purchasing. We're thinking about inventory control. And we're thinking about quality control, or, as you know, I like to say quality assurance. Facility location is simply this: putting your facility in a certain place, centrally located, to service your customers and be close to your suppliers. Now, obviously, we know why you want to be close to your customers. That makes sense. But close to your suppliers means it's going to cut down on their transportation. And if it cuts down on their transportation, it's going to cut down on your bill. It's as simple as that. This is making an ethical decision. Again, I encourage you to look at these things. You can see it on page 246 and think about it. Operations management on the internet. Yeah, we can do that because there's some engineering can be done by the internet, and just have to figure out how you want to do it and work through that process. Location of facilities, again, is something that's very important. I mentioned before in the course that it doesn't seem to make much difference what product you're trying to sell or what business you're in, especially if you're in the fast food business. It's location. And after that, it's location, and after that, it's location. You need to be able to have the amount of foot traffic in that is going to make a difference between whether you're going to be solvent or you're not going to be solvent, whether you're going to make a profit or you're not going to make a profit. where you're going to make a profit and be able to do more. And part of this talks about allowing people to telecommute. We talked about that before. We'll talk about it again next week. It's something that's good, not good for everybody, and companies have to figure out what is best for them and to work in that fashion. Well, you have to set the facility up, and the facility has to be user-friendly. Now, what I mean by user-friendly here is user-friendly for the employee. The employee has to have, have some economies. Yeah, I mentioned before, you don't want to walk across the room if they don't have to. And so we need to do that. So it has to be efficient and promote efficiency and let people work as they're at peak efficiency. And when people are working at peak efficiency, they're more effective and they don't get tired as quickly. And, when you're doing things that you don't need to be doing that are not job related, it causes your mind to wander and it's hard to stay on task. That's what you want to do. And then for our customers, we want it to be customer friendly. They can find what they're looking for. That we have people there to help them when they can't find what they're looking for, or to provide advice for them, etc. So notice this is a two-pronged thing, this facility layout. Production efficiency and good service to the customer. Now there's different kinds of facility layouts here, and we can see these pretty much graphically displayed in figure 9.2 on page 248. The assembly line, where workers do a few tasks at a time and pass it down the line. Modular layout, where you do more work and sort of complex, and people work together to produce the final product. Fixed position, where you have the workers congregating around what's being produced. And then a process layout. Similar equipment and functions are grouped together. And you can see these, as I mentioned, on page 248. It's a little difficult to see in this assembly line layout from the slide, the modular layout, and they give some differences in systems. So let's look at what's on the thing. The product layout would be the assembly line. Process layout we use here for different customer needs, they show it. The modular layout can do changes in design or customer demand. And the fixed position would be a house. And what the idea of the fixed position is that different people can work on different parts of the product or the production at the same time. A couple of methods to do this: materials requirement planning and then enterprise resource planning. These are both computer systems, and the enterprise resource planning is a little bit newer, a little more up to date. And notice that it started out using sales forecast to make sure parts and materials are available when they're needed, etc. Really big deal, because if you're paying any attention, if you have built up inventories, that's costing you money. You have to store them and a few other things. Purchasing is just making sure that the company has, the manufacturer has on hand what it needs to have on hand in the quantity and the quality required at the best possible price. Very important type of things to do. And of course, the internet has really helped in doing this particular type of service. Now, this is one of the newer things, one of the things that the Japanese manufacturers perfected. We find a lot of ours are into this today, a lot of our manufacturers, and that is just-in-time inventory. The object here is that the manufacturer and the manufacturer's suppliers work together, and the supplier delivers the raw material to the manufacturer just in time for production. Now, that doesn't necessarily mean it's going to come right at the time they're ready to do that production. In other words, if production is going to start at 7:05 now, production is going to start at 7:07. That's when the product's going to get here. But it's going to be somewhere in a very short period of time that it's not going to be on the manufacturer's shelf a long period of time awaiting production. It's going to be used very quickly. And this allows minimum amount of inventory to be built up because, as I mentioned, if you have inventory you're paying for storage, you're paying for utilities, you're paying for all sorts of things. Maybe paying for security to keep people out, keep people from sabotaging. Unfortunately, that happens. So that's the object of just-in-time inventory. The big key here is that the manufacturer and the supplier have to have a good relationship. And kind of like the supplier telling the manufacturer, hey, excuse me, the manufacturer telling the supplier, I'm going to use these things and I want to do business with you. And I want to do business with you if you're going to give me a quality product and you're going to get the product here when I need it. And so it's a symbiotic relationship. The manufacturer's guaranteeing business to the supplier, and the supplier saying, yes, I'm going to take care of you. I'm going to give you the product that you need. And of course, if they don't do that, then you can look for a different relationship. So there's a coordination thing here. There's a trust thing here, built up over a period of time. One of the things Toyota does, for instance, when it's changing a product or doing something, it brings the suppliers in and says, this is what we do. Can you handle this? Quality control, this is just quality assurance, I like to call it. This is making sure that quality is in every step of the production process, starting from purchase of raw material. And then making sure that quality continues all along the line. And notice what they talk here about reducing errors. Well, of course, that's doing the monitoring, and that's making adjustments, as we talked about back in Chapter 7. And comparing results against probably standards, and then taking corrective action when it's necessary. No, it's not just waiting until the end of the production run to find out if it's good, bad, or indifferent. It's all through the production run. Now, pardon me. Today, most quality is measured somehow statistically. The father of this was a gentleman by the name of W. Edwards Deming. He was a statistician, and he was on General MacArthur's staff after the Japanese surrendered, and MacArthur was, excuse the expression, the Emperor of Japan, even though he wasn't. People thought that Deming was a pest, and so at MacArthur's behest, or some of his staff's behest, Deming was sent over to work with the Japanese, and he taught them what's known as total quality control. But we don't talk about total quality control in the text here, and I'm not going to, although Dr. Deming is mentioned here, but we don't talk about total quality control the way Deming talked about it. But one of the things that Deming did espouse, and most people who've gotten into the quality business talk about, is checking quality by statistical analysis. One of the most popular one today is Six Sigma. And Six Sigma has been popularized by General Electric, among other corporations. And notice that Six Sigma allows for 3.4 defects per million opportunities. And that comes out to 99.7777, that 7 runs out pretty far, percent quality, very high. Now there's a couple of other ones that are out on the market today: statistical quality control, statistical process control. They're both mentioned in the text. Statistical quality control is just a measurement, statistical measurement to check throughout the production process, and the process control, testing statistical samples of product components at each stage of production. So that's what I'm talking about quality assurance. I wanted to read that because I have a little trouble getting that into my mind. It's exactly what that says. And if I don't stop and read it, then I'm going to say something that's wrong, and I don't want to do that. I'll leave you with a bad impression. So it's important that quality be measured through the entire production process, because if it's not, then you're going to have some part of the production process that may be faulty, and you won't know that until the end product comes out, and you're culling the end products, you're doing the quality control thing, you're throwing things out, but you still haven't figured out where the problem is. And that doesn't do you any good. You have to know where the problem is so you can fix it. If you don't know where the problem is, it's not fixable. And so you're just back into the same things, and you're kind of spinning your wheels. And you don't want to get to the end and throw stuff out, create additional scrap and waste. I'm not going to spend any time on this. This is the Baldrige Awards, and it's companies that go through this process, and there's hoops that they go through, and then they go into competition to see if they win this Baldrige Award. Malcolm Baldrige was a former Secretary of Commerce, I believe, and I don't remember what administration he was in, and he was interested in quality. And this is called the Baldrige National Quality Award. And it is not just for manufacturing, it's for service as well. And then here's some of the various winners of the Baldrige Awards. Notice Montgomery County Public Schools in Rockville, Maryland, a suburb of the District of Columbia. ISO, International Organization of Standardization. This is worldwide. It is very prevalent in the European Union. And if your companies do not meet ISO standards, ISO 9000 or ISO 14000, you probably are not able to sell your product there. They're very, very big on this standard, and you really need to follow. 9,000 is quality management assurance, and 14,000 is best practices. We're coming to the end here, and we have two things to talk about: the PERT chart and the Gantt chart. PERT chart, Program Evaluation and Review Technique. This is a method that's used a lot of times by engineers, but a lot of times by product managers as well. And you can get some idea of completing a project and know where the choke points in the project are, and work on the most important parts of the project first. And to give you a little bit more information here about it, analyzes the sequences of tasks, gives you some kind of an idea of start time to task completion time, and it also identifies what's known as the critical path. Sometimes you will hear the PERT chart referred to as the critical path method. They're kind of synonymous, a little bit different. Notice it's the sequence of tasks that takes the longest time to complete, so you have an idea of how long it's going to take you to do something. In correlation with that, here's a PERT chart for a music video, which you can see at the bottom of page 252 in figure 9.3. And then in correlation with PERT chart, we have something known as the Gantt chart, which was named after Henry Gantt. And it does a similar type thing to give you some kind of an idea of how you're going to sequence tasks. And this is one for a doll factory, which you can see on page 253, figure 9.4. So it tells the production manager when he looks at this is how far along production is in various and sundry things. So he gives an idea. Notice they have a couple of things at the bottom. If you look down here, the white bar shows completed work, whereas the colored bar, that's sort of an orangey color here, shows work that still needs to be completed. So it gives them an idea of where they are with production, and then looks at different type things, and so they can give some kind of an idea of where they want to go, what they need to do, where resources need to be placed, etc. Well, that brings us to the end of chapter 9. I want to thank you for your attention. We spent the last almost 3 complete what is known as hours, clock hours if you want to go there, speaking about control, the 4 functions of management, and then getting into restructuring, and then finally into production and operations management. Next week, we're going to talk about, again, I think 3 very interesting chapters. Chapter 10, Motivating Employees. Chapter 11, Human Resource Management, which is subtitled Finding and Keeping the Best Employees. And then finally, Chapter 12, Dealing with Union and Employee Management Issues. So again, I thank you for your attention, and I will have this uploaded. Remember, there'll be 2 separate uploads tomorrow like there were last week. I'll let you know which one is which, and give you links to YouTube, as well as letting you know when they've been uploaded to, along with the lecture notes. Excuse me, I couldn't stop thinking. So thank you very much for your attention, and good evening.